Welcome to today's video. We'll be going over cosine. Many of you might remember cos or cash or whatever you like to call it, a theta. Today we'll be finding angles and sides using cosines of right triangles and non-right triangles. Before we begin, I want to go over a few things covering the ACT portion of like how trig is weighted and relating that to your score wise. So 5 to 10% of the ACT is trig, which comes out to be 3 to 6 questions. So based off that, you can find by just looking up a ACT scoring chart. This is based off the free test given through like different websites and the ACT specifically. So that if you get everything else right, that gives you a minimum of 54 to 57 points based on how many questions you got. So that's for 54 you can get a 33, 57 you can get a 35. So it's not a big difference to getting a perfect 36, but so it's only going to bump you down 2 points or so, depending upon where you're sitting. So if you're struggling with trig and you don't quite remember it come test day, don't freak out. Skip over it. It's not going to affect your score that drastically. Focus on the other questions. Besides that, let's move on. So, ACT covers basically they cover right triangles and non-right triangles. So, we'll go over how to find an angle and a side using a right triangle. So, they'll give you a right triangle and they'll give you, let's say, a 5 and a 4. And they're going to ask you for theta. If you don't remember what cosine is adjacent over hypotenuse. So your adjacent would be here, which I'll just call it A. This will be H. Or you can just put hypot. Alright. So this is your adjacent side. This is your opposite side compared to your theta point. There's only one problem. You don't know your adjacent side. So how do you find your adjacent side? You use Pythagorean theorem, which is a squared plus b squared equals c squared. So we'll keep it a since it's adjacent. We can call this b and that's c. So you can just plug it in the equation and say this is 4 squared, put a squared there, a squared plus 4 squared equals 5 squared. Compute it out, so it's still a squared plus 16 equals 25. You subtract the 16 on both sides. I'm getting ahead of myself. Which gives you 9 equals a squared. We'll want to solve for a just by itself. So a equals 3. So So this adjacent side is 3. Since you know that, you can now most likely have it in a fraction form. Notice that the answer will be 3 adjacent over the hypotenuse, which is 3/5. So, recapping, though most likely this works either for sine or cosine. They'll give you the opposite side. You have to find the side, and you have to plug it in, compare it to the fraction of cosine or sine. Moving on, we'll find, given that you have a, we'll say this is a 50-degree angle, and they give you we'll say this is 6, you have to find that. So how do you do that? You know that this is your adjacent side, this is your hypotenuse, and you have a cosine of 50. So you can set them equal to each other, because this over this should equal this angle. Due to our definition up here, this will be your of theta. That's theta, not a 0. So cosine of theta is adjacent side over hypotenuse side. So basically, your adjacent side goes here. You don't know what that is, so we'll just say it's x. And you can put your cosine of 50 and put it over 1. Then you can cross multiply, and this is cross multiply. So this is x cosine of 50 equals 6. Divide by cosine of 50 on both sides. That is, if you want to calculate it out, make sure your calculators is in degrees. If it's for some reason in radians, so it takes, I'll just do it this way, and I'll just put the answer. Do 6 cosine of 50, and you should get 9.33. I'll round to 2 places, so this will be what your hypotenuse is, which makes sense comparatively because your hypotenuse is always bigger, so we know it's right. If you want to, you can, if you really want to check it, you can take the inverse cosine, which helps, knowing 2 sides, you can find your angle. So you can take 6 over 9.33, and rounded, you basically get 50. So we know that it's the correct length. 9.33. There we go. Moving on. The ACT also like to give you non-right triangles because we'll just go like We'll say this is not a regular isosceles triangle. And we'll go more sideways with it. Now, I'll probably just bring it out this way and just gonna, so it doesn't look like a pyramid. There we go. So that's better. So most likely they'll give you, this probably is the longest side comparatively, because we'll just say this is a 35-degree angle. This is this is probably not a good example. Try again. Right triangles have a lot to be desired for. That's better. Okay. I like that one better. Alright. Most likely they'll give you a dotted line, give you a story problem with it, yada yada sometimes, and say that this is, we'll say 18, this is 26. And this angle right here is, I wouldn't say that. I would say 30. There we go. That's decent. Alright. With that, they'll say, what's this length? Well, you don't know, because if you remember, a angle with a side, an angle and a side, this is your side, here's your angle right here, and here's your other side, going left to right, is a cosine related problem. That is the only way you can do it. And how you find that, if you can remember, is the law of cosine, which is a fancy equation to find this if you know two sides and an angle. So it's basically c squared equals a squared plus b squared minus 2ab cosine of theta. Some equations put like a big C because C is across from C, but theta is what we use because this is the angle, which is theta, which we don't know. So we have to find the angle to put in the equation to find our answer. So if you remember, since this is along a straight line, you can use complementary angles and say 180 minus 30, which gives you 150 degrees. So our theta will be 150 degrees. So, based off that, we can now use our equation. On the ACT, they're not going to ask you for a specific answer. They most likely will give you the answer in this form and just have C be solved. And they'll just have this be square rooted, this be square rooted. It's not flat, but it'll do. So C equals the square root of yada yada yada, a squared, b squared minus 2ab cosine. This is all under the square root of theta. And you have to find the equation with the numbers that are plugged in. So now we can say this is A, and this is B, this is our C. And that's our theta. Some equations will do a big C, but same idea. So c equals the square root of 18 squared plus 26 squared minus 2 times 18 times 26 cosine of, scoot it up a little bit so you can see what it is, our angle 150. There we go. And that will be basically your answer. If you do have to find it, which most likely you don't, because they want you to know the equation but not quite like memorize it. So if you remember a side angle side equation, it has to do with cosine. You can have it, plug it in to the equation. It will basically be a squared plus b squared, all that plugged in. Then all you have to do is find that in their answer, and this will be your answer. So that's finding angles and sides of cosines basically in a nutshell. I appreciate you watching this video. If you'd like to like, comment, and subscribe, and comment down below of any other videos that you would like to see done, you can comment down there. See you next time.